Hello, class. What's my character? MathemaGYPTIAN. All right. Today, as the MathemaGYPTIAN, welcome. Like the Thriller video. It rides up. Did you know Egyptian costumes tend to ride up? I did not. Now I do. So in addition to learning about that, let's go ahead and learn about circles. Okay, are you ready?
Yeah.
Nice. Are you ready?
Yeah.
All right, yay math?
Yay math.
Rock and roll. Okay. Do they say that? Or do they say like boulders and sand? They must say something like that. All right, so please draw a circle. I invented the circle. And a few things. Let's just go quick vocabulary. Here we go. What's this line called here?
Radius.
Radius. All right, we'll put an R here. What is this long line called?
Diameter.
Diameter, very good. So D. How many radii make a diameter?
2.
2, very good. Let's do a few more things. This thing called C, what does it mean?
Circumference.
Circumference. What does circumference mean?
Around the circle.
What about around?
The distance.
The distance around, what's another word for that? Starts with a P
Perimeter?
usually. Yeah, it's the perimeter. So it's kind of like the perimeter of a circle. What's the formula for circumference?
Pi d.
Okay, it's pi times d, or 2 pi r. Okay, so let's give this circle a radius. What do you want the radius to be?
5.
5.
7.
5. Okay, so what is the circumference or the distance around this circle?
10 pi.
10 pi. Any questions about that? We're going to go through it real quick. 10 pi. All right. Area, what's the formula for area of a circle?
Pi r squared.
Pi r squared. All right, so pi times what squared? 5 squared. 5 squared, so that's 25 pi. Okay, next topic, another circle. And now we do another radius in here. All right, and let's go ahead and give this some, let's put a diameter there. Let's go here. 120 degrees. Okay, 120 degrees. Is this angle yonder? The first Egyptian to say yonder. This is the degree over yonder. I'm sure Egyptians watching at home don't talk like that. I'm like an ancient one. As I demonstrate myself. 120 degrees. You guys have like fun energy today. It's fun. And I'm writing up there. Okay. If this is 120 degrees, let's go ahead and give this a radius of 6. Okay. Now, I'm calling this piece, we'll do it A and B. Okay. This length from A to B, what is that piece called? Does anyone know? Yes?
Radius.
No, the radius is from here to here. Talking from A around to B, it starts with an A. Yes? Yeah. Yeah, you were going to say it? It's an arc, that's right. So we're going to call this arc AB. And now some students tend to confuse this. I'm standing over here. Some students tend to confuse it. And there's 2 things that we're going to learn about this. There's the measure of the arc. And then there's the length of the arc. Okay. The measure of the arc is sort of like in degrees from A to B. In other words, the degree measure from here to there. Now you guys already know this. What's the degree measure from A all the way around back to A. What's that degree measure?
360.
360. Bravo. I'm an Italian. An Italian Egyptian. Bravo, bravo, welcome to my pyramids. No. Pretty good pyramid. I'm very stable. You know? And so that measure from A all the way around to A itself is 360, like you said. And the measure from A to B, how many degrees do you think that is?
120.
120. Very good. Let me put that in there. 120. So we can answer this question right away. 120. Okay. And now the length of AB. Okay? The length of AB has to do with the circumference. The circumference of this circle. Now, is the arc of AB the entire circumference of the circle?
No.
No, it's not. Why don't we go ahead and get the circumference of the circle first? What's the circumference of the circle? Please, in the back. Is that a hand, or were you just being like, okay, yes?
It's pi d, so it would be 12 times.
Okay. Circumference equals pi times diameter equals, what'd you say?
12.
12 pi, very good. Okay. So 12 pi is the length all the way around. But we don't want all the way around, do we? We want a portion of all the way around. What portion of all the way around do we want? Yes?
Like, isn't it just
Yes, right? From here to here. Around.
Yeah. So isn't A is also like that part is the radius? It's like A to the middle
A to the middle, okay.
is the radius, right?
That's right, that's also radius.
And then, so can't you add the two, or is that not
No,
how it
no,
works?
you're thinking of these straight lines, which are the radii here.
Yeah.
But what we're talking about is the arc
Oh,
length.
okay.
The red line that follows here to here to here. And we know that the whole, let me ask you this, what's the length from A all the way around to A? The length.
1.
12 pi.
12 pi, exactly, all right? So any confusion about that? The length from A all the way around to A is 12 pi, which is the circumference. However, we want a portion of that from A to B. Let me ask you, what fraction of the circle is from A to B? Yes. It's a third of the circle. How did you get that?
120 over 360 is 1.
Right. So let's talk about that. If you had AB for here, that's 120 over 360, which is 1/3 times
12 pi.
12 pi.
So it'll be 4 times.
So it would be 4 pi. All right, so do you agree that 4 pi would be the length from A to B?
Yes.
And that would be 1/3 of the crust of this Egyptian pizza. 1/3. I'm going to give you another one. Yeah, let's give you another one. Okay. Call this guy C. And find all right, good question here.
Yeah.
Please try to find the measure of arc AC, which we agreed was a degree thing. And then find the length of arc AC, which is a measurement. All right? Okay, we got one hand.
No, I have a question.
Question, please.
For the measure of BC,
Yeah.
if you have the answer and you add degrees or just leave.
You leave it as a number, yeah. That M requires just the number. But we know it's in reference to the degrees. Question or answer?
Would the angle, like, would that be 60?
A question and an answer. Question and an answer. Yes, it would be. Yeah, it would be. How did you get it?
Because it's supplementary.
Okay, supplementary, very good. You're using the linear pair rule, okay? Now what we can also do is, do you agree that if this line is a diameter, it cuts the circle into 2 halves? And how many degrees are each of those halves?
180.
Right, 180 is each of those halves. So if this half is 180, and this half is 180, and the friend is 120, then this must be what, everyone?
60.
60, very good. Okay, so 60 degrees here. So I'm going to pop that in, 60. Okay, and now we want a fraction of the circumference, correct?
Yes.
What fraction of the circumference?
1/6.
Please.
Wait, I don't know that question, but I have a different question.
Okay, please, go ahead. Yeah.
Okay, this might be stupid, but...
No, it's not. Moving. Moving. Move. Okay. Yes.
If the whole thing is 12 pi,
Yeah.
and that part's 4 pi,
Right.
and cutting it in half,
Uh-huh,
that
would
make
be-
that 2 pi?
Very good.
Okay.
That's a great method. That's
Okay.
a fantastic method. In fact, it's a time saver method, isn't it? Do you agree that the whole thing's 12 pi, you said? And so half of it would be what?
6.
6 pi.
Yeah.
And so the top half would also be 6 pi. And if the top half is 6 pi and the red piece is 4 pi, then the leftover slice would have to be what, you said?
2 pi.
2 pi. Okay, very good. Let's actually do it with a formula just to give people more exposure. So what's your fraction?
1/6, which is 60 over 360.
Right. Some people are comfortable going like this. They said, okay, take this number and put it over 360,
Which reduces to 1/6.
which reduces to 1/6
times 12 pi. Which
12
is the
pi.
circumference.
I'm merging my pi and my 12. 12 pi. What's wrong with my hieroglyphics are off today. 12 pi. And lo and behold, 1/6 times 12 is 2 pi. Okay.
So is that the answer for the length?
The length of AC. Very good. Okay, any questions? Any protests? Yeah, you got it, Okay. We deserve the right for good math. Peacefully. Okay. Let's actually take this down. And let's do the area. Area of the circle. What is the area of our circle in this case? Can someone say it offhand with the hands in the air? Hands up in the air. Yes?
36 pi.
36 pi, because the formula is pi
R squared.
r squared equals 36 pi. Very good. 6 squared. Okay. Now we're going to get it. What's your color of preference for shading?
Blue.
Blue it is. Let's shade this slice. Find the area of the shaded region. That's what it's going to be asking. The area of the shaded region. So, area equals what fraction of the whole area are we after?
A 6.
A sixth. Again, very good. How do you know that this is a sixth of the circle?
Just did.
We just did it. And what was our fraction to get us that 1/6?
60 over 360.
60 over 360. Is this okay? Are you, yeah, feeling okay? Okay. So 60 over 360 equals 1/6 times the area, which is 36 pi. And that becomes what?
6 pi.
6 pi. So this area here is 6 pi. Okay. And now I'm actually going to play on your method, what you did earlier. Check it out. What if I want the area of the red? Area of the red portion in here.
6
Multiply
pi.
by
6 pi.
3.
Multiply it by 3. Awesome.
Now we get it.
See that? Because actually multiply it by 2. The whole thing is 3, isn't it?
Yeah.
Yeah, the whole thing is 3. But if this is 60, how many 60s go into 120?
2.
2, right? So if this is 6 pi, how many 6 pi's would go in here? 2 6 pi's, making what?
12 pi.
12 pi. This is 12 pi in here. Okay, so that's a good way to do it. Last topic, and then we're done. Done and done. Why do people say done and done?
Redundant.
It's redundant. It's redundant.
I get it.
It's redundant and done and done. I knew you guys wouldn't let it go. I've done that. Sometimes I'm like, think!
You.
And people are just so, they have to say, nks.
Oh.
I just stopped at
I
A.
changed.
Think. The people can't let it go. All right, last one. Okay, Cirque du Soleil, set it up.
I get it!
Nothing like a high pitch, I get it. And rock and roll, we do this line here. Almost looks like the beginning of a one of the striped balls in a pool table, but it's not. You know, if I were to add another one down here, let's go ahead and do it. All right. Anyone know what this line is called? Yes.
It's a chord.
It's a chord. Very good.
Chord.
Chord. Almost on time, but no. Chord. Okay, Jungle Man. So, the chord. What's the definition of a chord? Can anyone make it in their own words? Yeah.
It cuts across.
Right.
the circle.
Cuts across the circle. Can a chord be a diameter?
Yeah.
It can. Very good. Yeah. Any line that goes from one end of the circle to the end, including the diameter. That's right.
Is it the same measure as the diameter because the circle, no matter how you turn it?
Right. If a chord goes through the center, it's a diameter. No matter
No,
where.
the measure.
The measure.
The measure of the diameter would be the same as the chord.
No, because it goes.
If it is a chord, yeah, like you're talking about this. That chord is a diameter.
Okay.
No matter how it goes through the center, even if it went through like that.
Wait,
Right.
but what if it was on top? Like the highest chord? That's not the diameter.
This one here, it's not the diameter, correct. Diameter goes through the center. Very good.
How do you do it?
So now let's talk about some characteristics. The distance to the chord. The distance to the chord. Would the distance to the chord ever be this line
No.
or this line?
No.
The distance of the chord to the chord would be what kind of line?
Radius? Never mind.
No, not necessarily a radius. Good guess.
Wait,
Someone
what do you mean
else?
The distance to the chord.
The distance, how far is this? If I wanted to draw a line that was the length from this center to this chord,
Straight up.
Oh, it would always
Straight
be
down.
perpendicular.
straight up, yeah, what's one characteristic that's
Perpendicular?
90 degrees.
perpendicular, 90 degrees. That's right. So let's go ahead and do that. So the distance has to be at a 90-degree angle. Okay. And now, once you have a distance to the chord, what happens to the chord with this distance? Does anyone know what happens to the chord?
Bisected.
It's bisected. That's right. Right. So now this chord is cut into two equal parts. So, here we go. A, B. Chord AB equals 8. Notice it's a straight line now on the top, right? It's not the arc AB, it's the chord AB. Okay. Okay. Distance from C to AB equals 3. So I'm going to just put that number in there. 3. What are these two pieces of the chord going to be?
4 and 4.
4 and 4. Any guess what the question will be?
Like, how big is the hypotenuse of the triangle?
You're one step ahead of me.
Oh, what's the different distance from B to C?
Oh, what's the
What's the
radius?
radius?
That's right. What's the radius of this circle? Okay. So take a minute to think for a sec. Okay, we got one answer. If you know the answer, maybe hold it up with your hand. It's a good method.
Oh.
Right, it almost looks like a question, right? Like question? No. Right, yeah. It's a good method, actually. Hold it up with your hand. How are we getting 5, please?
Well, it's because the
Yeah, starts with an H. Hypotenuse, yes.
hypotenuse is
Hypotenuse is
fi- 5?
Yeah, you got the answer. That's why I'm asking you. The hypotenuse is 5. Can I draw the hypotenuse, please?
Sure.
No, you didn't.
Thanks. All right. There it is, isn't it?
That's a good one.
Or here, right?
Yeah.
But not really somewhere else. It wouldn't really help us. I mean, this is also a hypotenuse, or not a hypotenuse, a radius. This is a radius, for example. But it doesn't really get us near the action. So indeed, how do you know what this is now? Yeah,
3, 4, 5.
3, 4, 5 triangle, that's right.
Well, it's only.
Or you
the-
can use
the
Pythagoras.
Or
radius.
Pythagorean theorem, if you're unfamiliar, bless you.
I mean, it's only the radius because it ends.
It goes to the edge, yeah, yeah. And now, last question of the day. What's this line right here? Don't call it out, hold it up with your hand.
What?
Bless your soul. This thing's like on its last legs.
Wait, what's the question?
What is the length of this little cat right here? Peace. Yeah, peace. What a good way to end. Peace. This is our solidarity with all people in search for peace. We love you. Don't we? Yeah. What'd you say? 2. That's right. How are we getting 2 for this?
5 minus 3.
Yeah.
Minus, 5 minus 3.
Well, what are you talking about? What's 5?
5 is the radius.
5 is the radius indeed from here to here. That's right. So if the radius is 5, piece is 3, then piece is 2. Piece is 2. Indeed.
I thought the answer to everything was 42.
No.
That's the answer.
No, that's that. If you've been using that rule up to now, I'm sorry for your troubles.
It is really. Wait, what do you mean?
It is the answer to everything.
The answer to everything's 42.
I don't get it.
Man,
Okay, check his guys to the gods.
the answer to everything in life is 42, right?
Yeah.
Yeah, okay.
Really confusing.
It's not.
This is pregnant Egyptian. This is full term. Yeah, it's not working. Okay, thank you, class. Give yourselves a hand. Hey. MathemaGYPTIAN will be back for more on circles. All right, take us. So give me the song. Coat hanger. Bye.